I'm Sarah Hakala, and this is my molecule, C5H10O4. This is it drawn out all pretty. We have our 5 carbons, our 4 oxygens, and our 10 hydrogens. These carbons right here are all similar. They're all in tetrahedral shape, and their hybridization is sp3. This carbon over here is a wild one. It's trigonoplanar, and it has a hybridization of sp2. There are a total of 18 sigma bonds, which are the single ones, and 1 pi bond over here, this double bond. And this whole thing, this whole molecule has a total of 54 electrons. And this is actually our empirical formula already. You don't have to do anything to it. It's as simple as it can be. And then over here, I found out the percent composition of each element, and I did that by looking at carbon first, and each atom of carbon weighs 12.01 grams, and I multiply that by 5 because there are 5 carbons in our molecule. And then did the same for hydrogen. I looked at its atomic weight, and it's 1.008, and I multiplied that by 10. And then for oxygen, I did the same, 15.999 times 4. And I added all those numbers up, and I got 134.131. That's the total weight of our molecule. And then what I did, for example, for carbon, I took the 12.011 times 5, I got 60.55, and I divided that by our total weight, 1.34 times 131, and basically I just like cross multiplied all this stuff, and I got 44.77% for carbon. For hydrogen, I did the same, multiplied 1.008 times 10, divided it, all that, got 7.52%. Oxygen, I got 47.71%, and all that added up was a total of 100%. Over here, I looked at if we have only 34 grams of the substance, how many moles do we have? And I did that by looking at, I put 34.6 grams of C5H10O4, and I put 1 mole of C5H10O4 weighs 134.131 grams, which I got by over here adding all those up. And I basically just divided 34.6 by 134.131 and got 0.258 moles of C5H10O4 when we only have 34.6 grams. And then down here, I balanced our equation when it reacted with oxygen. So I have C5H10O4 plus O2 yields carbon dioxide and H2O. And when I first started, there were 5 carbons on the reactant side, 10 hydrogens, and 6 oxygen. And on the product side, there was only 1 carbon, 2 hydrogens, and 3 oxygens. After I balanced the equation, there are now 10 carbons on both sides, 20 hydrogens on both sides, and 30 oxygen on both sides. So we got 2 C5H10O4 plus 11 O2 yields 10 CO2 plus 10 H2O. Okay, and then the next thing I looked at was trying to figure out whether our molecule or O2 was the limiting reagents. So if we only have 34 grams of our molecule, so we have 34 grams of C5H10O4 to work with and 19.6 grams of oxygen. And so what I did first, so I took the 34.6 grams of C5H10O4 and I figured out, or I put 1 mole of C5H10O4 is 134.131 grams. And then I referenced back to our balanced chemical equation, and I found, so for every 11 moles of oxygen, we need 2 moles of C5H10O4. So then I went and put 1 mole of O2 is this much. And I just did all this math, and I got 45.39 grams of oxygen is what we need to completely react with all that. But since we only have 19.6 grams of oxygen, O2 is the limiting reagent. So when we figure that out, we can come over here and figure out how much CO2 is generated when we only have these 34.6 grams of our molecule and 19.6 grams of oxygen. So I started with 19.6 grams of oxygen, converted that to 1 mole of oxygen is 31.998 grams. And then for every 11 moles of oxygen that we use, we produce 10 moles of carbon dioxide. And I did 1 mole of carbon dioxide weighs 44.009 grams. And I was able to cross out all these, what are these called? These little guys.
Remainders?
No, the... you know what I mean. These thingies. And, and I got 24.51 grams of carbon dioxide is generated. And then I looked at how much H2O is generated. I did basically the same thing, but instead of... I looked at the moles for H2O, this should say... So I got 19.6 grams of O2. 1 mole of oxygen, O2, is 31.998 grams. For every 10 moles of H2O produced, we need 11 moles of O2. 1 mole of H2O is 18 grams, and I found that we generated 10.02 grams of H2O. Yay! And that's it. That's all of it.